horizontal pod autoscaler. సో మనకి kubernetes ఫీచర్స్ లో ఇది ఒక హై అవైలబిలిటీ ఫీచర్. దిస్ ఇస్ ద బెస్ట్ ఎగ్జాంపుల్ ఫర్ అప్లికేషన్ డిప్లాయ్మెంట్ providing high availability features. HPA is the one of the world best component. So Kubernetes supports two types of autoscaling. One is horizontal pod autoscaler, another one vertical pod autoscaler. So here horizontal pod autoscaler means inside the cluster we have multiple nodes. So in that multiple nodes we can deploy application in the form of different pods related to services. So this kind of deployment we can call as horizontal pod autoscale. So how this horizontal pod autoscaler providing autoscaling means, see, in Linux, see, this is the deployment file. See, apps, API version, apps v1 kind deployment. So I have defined all the things. The container section, I have taken stable version. See here, stable perl tag. So if you want to do any auto scaling, mandatory, we need resources is mandatory. If you want to collect the resources, then only you can achieve auto scaling features. So for that, I have defined resources requests CPU 120 MB, 120 millicore CPU and memory 150 MB and limits CPU 150 and memory 200 MB for each pod, Nginx pod. For that, I defined a service. See here, this is the service definition file. I'm using load balancer. Oh, just a minute. Nginx -H. Is the definition file which I have written. So next, discuss about vertical pod. Vertical pod autoscaler means inside the cluster we have large resources, kind of one server only. Inside the server, we can deploy multiple pods. This kind of autoscaling can be called as vertical pod autoscaler. Remember these two variations. See here, this is the EKS cluster. So inside we have multiple pods. I have created five nodes. 1, 2, 3, 4, 5. So each node you can deploy services in the form of pods. So maintain all nodes, these services which Nginx related services deployed each and every node. This kind of deployment used for vertical pod autoscaler. So remember this. See, instead of taking multiple nodes, take one node only, high configuration node. See here, this is a two core CPU. Two core CPU means you can take single node, 10 core CPU like that, and 8, 8 GB each node have 8 GB RAM. So 5 8 40. You can take 40 GB RAM directly. So this kind of deployment, vertical pod autoscaler. Remember this two variations. That's it. Next, to install metric server. See what is metric server. Understand now. See, this capture the node consuming resources from the cluster by using these resources. So this metric server analyzes that resources and it maintain the backend those components which pod how much C, CPU usage and how much memory usage. This kind of analysis this metric server can do. For that we need to install this metric server. Oh, now metric server installed. Check inside the kube system namespace. kubectl cluster managed services, all services available in the kube system namespace. Remember this one also.
Parshram, can you repeat it, that cube system once again?
Cluster components managed services means if backend creating controllers and backend components is managed by kube system namespace. Kubernetes have specific namespace that can be managed these related components. See, hyphen n. See here, metric server is successfully running one by one status. Now Next, metric server is the application. It captures all pods consuming resources from the cluster. Remember this point. For that, we need to define resources inside the deployment definition file. I have defined like this: resources, requests, and CPU. Understand? Next, we need to install one more Apache benchmark. So currently we are using Ubuntu server, right? That's why we need to install Apache benchmark, which is related to Ubuntu. So go and search the Google and Apache benchmark. So you need to understand each and every component for theory purpose. These are the tags, instructions, hyphen. So you need to understand each and every. The Apache benchmark is a tool for benchmarking your Apache hypertext transfer protocol HTTP server. It is designed to give you impressions of how your current Apache is. Some information missing here. Mostly it is checking only performance purpose, application performance. See, I am deploying my Carvel applications. So I want to improve my application high availability features. So in that case, we need to use Apache benchmark. This kind of application support performance testing. So after installation and deployment, after deployment, you can understand what it is, what's going on. So you can use JMeter and other TeamCity, some other tools also there for testing, application performance testing. So if main purpose is this benchmark, my application accessing a huge traffic. So each each request, how many milliseconds it is going to access, and my my server, how many requests allow for each millisecond. So this kind of testing we can do by using this Apache benchmark. Next, so this is the URL for installing Apache benchmark on Ubuntu. So they are giving instructions. So you need to follow these instructions. First, update the repository. Next, you need to install Apache benchmark available inside the utils. Util package contains all Apache related packages. So just you need to install this package, utils package. So already I installed. So that's why it is giving it is a newest version. So how we can check just the AV. Apache benchmark short name is a AV. -v. If you want to check specific version, which version you have installed, so use purpose. Version is 2.4.58. So successfully installed Apache benchmark. So we'll get this output, right?
From
Yeah.
why it is needed? You installed Apache benchmark, right? What is the use of that?
See here, our application user accessing concurrently 10 lakh users. So, but you need to allow only specific users, so like that 10,000 users login. So using application. So every millisecond. So this kind of test analysis, this benchmark can do. So next, deploy the application first. That Nginx HB. Now we can deploy this. kubectl apply -f. Nginx HBA file name. So successfully created. Check kubectl get pods and SAC -o wide is running. This is the DNS for load balancer. Copy this load balancer. Replace. Try to access application once from the browser. Or you need to click call command by using call. Paste the DNS. So application is accessing. So try to access from the browser also. So my Nginx is available. Change the DNS, this DNS, and paste. Here 1 lakh current concurrent users accessing my application, but customers only every millisecond access trying to access under 1 lakh users concurrently, but here customers 1,000 customers only accessing application every millisecond. So the this will replace 10,000. What will happen? N means number of users. Remember, this is the customers. See how many customers log in into the application. Clear view CTL top pods. Here one core CPU currently using one just here 1 millicores it is using. So memory 3 MB. This pod will consuming. So after hitting this URL, that is going to be increasing. See here. So too many open files. So we need to reduce this customer request 5,000. This is also not accepted. Give 2,000. So 1,000 finally. See now it is accepted. See how the load will increase. 30 millisecond, 30 millicore. It will increase. See 150. So like that, automatically horizontal pod autoscaler will uses these resources and provide the high availability for application to the users. It get reduced. Completely down. With request completed. 1 lakh requests completed. Here, first 10,000 requests completed. Next 20,000, 30,000, 40,000, 50,000, 60,000, 70,000, 80,000, 90,000, 1 lakh. 1 lakh requests finished. This is the DNS, this is the port, the default slash. See here concurrently, concurrency level 1000. So I given 1,000 users login into the application. So taken for test. So 51 total, 56 seconds. Completed request 1 lakh. 1 lakh request completed within 1 minute. So can I, we can able to analyze this kind of analysis by using Apache benchmark. See total transferred bytes, HTML transfer, these many bytes, request per second. Each second, 1777 requests processed. Time per, time per request. Total milliseconds, 562 milliseconds taken. So time per request, 0.56 milliseconds. Less than 1 millisecond across all concurrent requests, means all users. Transfer rate, kilobytes per second received, these many kilobytes, 1472. Connection minimum 1, CR maximum 1000 plus, 1069, 1069. Processing 33. Waiting. So this is the analysis. Total longest request 38,000, 3,805 longest requests received at a time. సో మీకు డౌట్స్ ఏమైనా ఉంటే క్లియర్గా అడగండి. ఒకసారి నేను ఇది ఆఫ్ చేస్తున్నాను.